Okay, in this tutorial, we are going to take what we learned in the 3D um, player or enemy AI tutorials. We're going to apply it to a 2D context, and we're going to learn about raycasting and basically like how you can have an enemy patrol along a platform and stop and change directions at the edge of the platform. So rather than the turret scanning, right, you're going to be able to essentially have the enemy activate and get essentially agitated when the player gets closer. Okay, so let's go ahead and get started. Now, we're going to start with the scene. If you've done the 2D tutorial previously, we are going to start with the outcome of that tutorial, right? So, and really the only important thing, the only thing we really need in there is our player, right? So you could go ahead and make Bobby a prefab if you wanted to, but it's going to be easier to do the changes if he's just an object. So we can there's two ways we can go forward from here. If you'd like to just be able to use Bobby for as your player controller for future scenes, what you can do is you can come down here and you can go to Save as Scene Template. And this is really useful if you're, say, creating a game or an experience that has, if you had, say, 30 levels or 30 stages or, something like that, you can create you can have your camera set up right, you can have the camera follow, you can have the character, you can have maybe some base units in there and any post-processing effects and, other things that are important to how your gameplay goes that you don't want to have to recreate for every scene that you start. You can create a template to do that. And so you just save it here. I'm not going to do that because I've already saved it as a template. So then once you do that, you go to Open Scene. You go to New Scene. And with New Scene, right, there's all of these options. And one of the scenes that I saved was this 2D template. But what you can do, and if the dialog pops up, if I select, it's not going to work there. That's all right. But when you go through the creation process, the inspector will have more information and you can name the scene. So the scene will have this title when it's in your project, but you can name the template different things. So you could be like, best 2D game ever level 1 template, best 2D game ever level 2 template, etc. But we're going to take, our template, you could also just save as, and create a new scene. But I'm going to call this 2D scene enemy AI-toot. All right, and so I'm going to go ahead and save this. You can see I've already tried this tutorial several times and failed miserably. So there's multiple copies of this already happening. So you'll see everything looks the same, but my file name changed, or my scene name changed. And so there's a couple things we're going to get rid of, which is basically everything right now. And there's a couple other assets we're going to add. So first, when we created this scene, initially in the tutorial that I did this in, we went from 3D mode and we switched to 2D mode. And one of the things that I neglected to delete was the directional light, right? If I uncheck this over here, that turns the light off. And you'll note that it doesn't go black. All of these objects are still luminous. And that's because in 2D mode, it defaults to having what are called essentially like unlit materials, right? Where they don't need light to be applied to the surface in order for you to see them, right? They don't, shadows aren't going to be cast on them. They don't cast shadows. They just, are full brightness and intensity. And what's nice about that is, right, it saves some processing, some GPU cycles and things. It's not as intensive if you have no lights in the scene. So I'm going to go ahead and just right click on that and delete that one for sure. And then the other objects I want to delete, I'm just going to go ahead and delete the platforms I've got and all the other objects in here, except for my scene variables and my main camera. So I'm going to select the square. I'm going to hold down Command or Control if you're in Windows. I'm going to get the checkerboard, the banana, square, and the other square. and I'm going to right click and I'm going to delete those. Now, we're going to be importing assets that, if you're in the course, they're going to be available on Canvas. If you're not in the course, you can just find anything you want. You could honestly leave some of these assets in here. Basically, we're going to need 2 platforms. So I'm going to go ahead and delete those. And let's go ahead and add our new assets in. So we're going to have a couple new assets. And one is going to be our platform, which is actually going to be this fish. And so go ahead and remember to right click, import new asset, bring those images in. And once you've brought the images in, make sure when you have it selected, you go up here and you change from default to sprite 2D and UI, and then you click apply, and do that to both the fish and then the mollusk, which I misspelled, but I like the way I misspelled it, so I'm keeping it. And then once that's happened, go ahead and drag a fish or 2 into the scene. And we're going to go ahead and drag 2 fish in here. And, okay. I don't know why I can't click. There we go. Now I can click on it. And then let's go ahead and drag the mollusk in the scene too. Now the mollusk is huge. This is like a boss level size sprite. So we're going to shrink that down a touch. We're going to hold down Shift and just make this a little bit smaller. And I'm just going to leave it kind of floating in space up here for now. Now there's a couple other components we're going to need to add to these objects and a couple changes we're going to make. First, I didn't realize it until I got this in here, but this mollusk is really hard to see against the background. So I'm going to change the color a bit, and I'm going to do that to the fish too because it's just fun. So one of the things you can do in the sprite renderer, you've got this color option here. And what that does is it basically just applies a tint. So, it doesn't completely overlap the image, but it applies a tint. So I can make this thing green or, yellow or magenta. And I just want to find something that really kind of pops out against that background. It looks like this kind of reddish orange might be the best option for that. Or honestly, the green, it's just a little too dark no matter what I do. Maybe I could bring this, up here a little bit. But that really just lightens the tint. So let's go ahead and bring it to this red-orange. Kind of, well, I guess it's more yellow at this point. And then if I select the fish, I can do the same thing. So I can say, okay, well, let's make the fish green because that looks great. And maybe this fish will be magenta or something like that. I don't know. And I have no idea what the concept of this experience or game would be. I don't know, fish platformer 2.0 or something. I don't know. Okay, so we're going to, let's go ahead and we need to add colliders to our objects that we just added. So let's select our mollusk and add component, and we're going to go down to physics 2D, and we're going to create a circle collider. And that circle is going to be way too big for our mollusk. So we're going to just set the radius to 2, which happens to just nicely fit around the shape of the object. And then let's go ahead and select our fish. And we can select both of these fish at the same time. And I believe we can just click Add Component and go to Box Collider 2D, and it'll create a box collider on each one of those objects. Now, the other thing we can do is what we're going to need to do is edit these box colliders because these colliders are huge. So I've clicked on the Edit button, and now it'd be great if I could edit them both at the same time. And what would probably make a lot more sense would be to just do this with one fish and then copy the fish in the scene. But I'm not the most efficient person at all times. So basically we want to make this platform about 1/3 of the thickness of the fish and from head to tail. Tip of the head to tip of the tail, and we're going to do the same thing over here and get these done. Because basically we want this platform over here so Bob doesn't fall off into infinity because he has a rigid body applied. And then this platform is the one that this mollusk is going to be patrolling. Okay, so we've got our colliders on there. Fantastic. Let's make sure that everything's set up right and so Bob doesn't fall through here. The mollusk should just sort of stay in space. Great, so Bob stays there. Bob is working. Fantastic. Now, before we go any further, I do want to show you one other way you can create a different type of collider that you can create. So, let's say that, maybe this fish is actually a much huger feature on our thing. So Bob is, maybe a third or even smaller the size that he currently is. And we want him to be able to traverse the actual profile of the fish rather than being on some default little box here. The way we can do that is rather than using a box collider 2D, we can uncheck that. And we can go to Add Component, and we can go down to Physics 2D. And there's a couple options. There's this edge collider that we could use where we would manually create that edge. Or we can go down and we can use the polygon collider. So the polygon collider, if I click on that, you'll see that it basically subdivides this sprite, which is already subdivided, but it takes this sprite and it chops it up into polygons, and it creates this nice outline of the fish. And so now this is my collider, right? And sometimes it might actually work to have both the box collider and the polygon collider on there, just because you can see right here, this would be potentially problematic in a place that Bob could get stuck or have some weird glitchy behavior. But if we have that box collider on too, then he's going to do like a smooth transition from the tail to this top fin. And so I'm going to go ahead and turn my box collider on as well. Now, what we could do is, we could end up creating a composite collider, but we're not going to talk about that in this example yet. So, okay, so that's just another way that you can actually use this. Oops, and I unintentionally applied it to both of these. So I am going to select this fish, and I'm going to delete the polygon collider, because, in this case, it's going to be a lot easier and it's a lot less processor intensive for the raycast that we're going to use to just be looking at a box collider. It's a much simpler object to look at rather than all the variations that are on here. And so it'll just make our life a little easier in terms of debugging at this point. Okay, so we've got these things set. So now it's time to start applying some behaviors to our mollusk. So our end goal is that the mollusk is going to be basically sitting still and then flipping the direction it's looking about every half second until Bob gets within a certain distance from it, and then it will start patrolling back and forth on the platform as though it has become agitated by, Bob's presence. It feels threatened by his amazing afro and painting talent. So let's go ahead and add these behaviors. So we're going to say Add Component, we're going to go to Bolt, and we're going to create a flow machine. Now, eventually we're going to have a state machine for the different states, but we want to program this more complex patrolling behavior first, and then we can add that into a flow machine, or into a state machine. So I'm going to say flow machine. I'm going to make this an embed, and I'm going to just title this, let's see here, I'll just title it 2D Patrol. And it could honestly be 2D Platform Patrol. Okay, and then I'm going to click Edit Graph. All right, so what do we need to do? Well, one of the things we need to do is we need to move this object back and forth. And so the unit we're going to use to move this, we haven't talked about previously, and it's the transform.translate unit, which basically is similar to the transform.rotate unit, right? We've used transform.rotate previously, but there's also transform.setRotation, and so what's the difference between these two? With set rotation, you actually have to get the previous rotation and add whatever number of degrees you want to rotate onto it, and then set the new rotation, right? And so what rotate does is you just feed in the number of degrees to move from the current position. So it eliminates a couple of steps. Translate's similar, right? So instead of getting your old position, applying however many units you want to move to it, and then setting it as your new position, translate just says, this is the number of units I want to move in this direction, and then it makes that adjustment. So it's it's sort of a quick way to do it. So let's go ahead and create that. So we're going to say transform.translate, and we're just going to say transform.translate translation. And the reason we're using translation is because the value we're going to be sending it will be a vector 3. And so we're going to do something a little different here as well, because, right, we're going to need to be able to flip this object's rotation. And it'd be really nice if we just had one speed variable rather than a positive speed and a negative speed, right? Because if we're not flipping this direction, we're going to be sending it this way, and then we're going to have to say, oh, well, now your speed should be being subtracted. And there's a lot of, there's more logic in there, and it's just a little bit more, it's a little bit messier. So let's go ahead and to start with, we will create a speed variable, and I'm just going to call it SPD. It's going to be an object variable for this mollusk. And I'm going to change this to, it'll be a float. And I'm going to set this to 5. It doesn't need to be very fast because this is a small platform, and if it's too fast, it's just going to be zipping back and forth across the platform, which isn't really what we want to have happen. So now I'm going to go ahead and drag this into my graph so we can get the speed. And surprisingly enough, we're also going to need time delta time, right? This is something that we do every single time, right? So that we can get this to work efficiently. And we're going to multiply these two values together, like always. And we're going to use a generic one specifically so that we can use it again in this next step. So now the question is, how do we determine what direction we're going? And yeah. So previously, the way we've typically determined the direction that we're going is by just saying, move in the x direction, move plus 5 units in the x direction, or move minus 5 units in the x direction. But what we want to do is we want to be able to flip the orientation of this entire object so that it's pointing, essentially the forward direction is pointing one way, and we're moving forward, and then it's flipping back the other way when we're moving across the platform the other direction. And so to do that efficiently, we're going to use the vector2.right unit. And what this does, if I just type in vector2.right, and I get that, what this gets is it basically gets the world orientation, if that makes sense. So what it means is this vector 2, right, is going to be just something that has an x value and a y value. The y value is going to be 0, and the x value is going to be 1, right? And the reason for that is if we have global set on here and I click on this, right, you'll see that this is the arrow points to the right, which means that positive values are to the right. So this is, x is 1, y is 0, because we're not worried about up, we're just worried about right. Now there's also vector 2.left, which vector 2 left, what that does is x is then -1 and y is still 0, right? So that means that if we and what we can do is we multiply this by our speed, and then so if we're moving if we are moving to the right, then it's whatever our, let's say 5 times 1 is what we get, but we get no vertical motion because that's 0. And if what's nice is we can flip our object around and then we go backwards. So let's go ahead and work this all out. Okay, so I'm going to go ahead and use a multiply again here. And you'll see that it wants it to be a vector if I do this way. So I need to actually type in MULT because we want this to be a generic, because we're going to be multiplying a floating point value by a vector, right? Which basically, when we do that, what it means is it's going to multiply whatever our speed and time delta time, whatever that product is going to be multiplied by every member of the vector, right? So it's going to be multiplied by x and multiplied by y. And y is 0, so it doesn't really matter. However, right, if this was to change in some way, shape, or form, or we were to use the local coordinates instead, we could then, this would aim in whatever, right, this would move in whatever direction we point. Even if we rotate it 45 degrees, it does all the math to make sure that our speed is correctly applied in both directions. Okay, so once we've done that, we can just take this into translation and we can click update. Now, I'm going to zoom my camera out a bit so we can see if this works. And let's go ahead and hit play and see if we move across the screen. Well, not we, but the mollusk. Okay, so the mollusk is moving at a uniform speed to the right. Fantastic. Okay, so we've got this set. So how do we determine if we want to, what direction we're facing? So the simplest way to determine what direction we're facing is to use the transform Euler angles set unit. So if I come in here and I say transform.Euler and Euler angles set, right? I get this unit, and what this does, you'll notice this is still a vector 3. And right, even though we're doing 2D stuff, we're still working in 3D space. All of these objects can be rotated around the z-axis if we so desire, right? So they could kind of flip and spin and do weird, strange things. And there's actually a couple, there's games I've seen that employ that, where it's all like 2D and then it pops into 3D and does weird, like strange things. When it's done well, it can be really entertaining too. So we're going to want to be able to transform this. So in this case, right, this is going to leave us headed in the right direction, I believe. And if we want to go left, what we would do is we copy and paste this. And all we need to do is put negative 180 in this value. And I may actually be wrong in terms of the orientation here, but we'll figure that out in a second. I mean, if it's backwards, we'll just fix it. So what we need to do is we need to figure out, right, we need a condition that's going to determine when this happens. Now, if we want to test this to make sure it's working, what we could do is we could have this change happen by just hitting a key to start with. So let's go ahead and do that just as a way to test and make sure we're doing things correctly at this point. So I'm going to go ahead and say on key. And what we'll do is we'll say on keyboard input. Sure, the space bar will work. Oh no, we're using space for jump for our character. Let's go ahead and just use F or something like that. There we go. So when F is down, let's just go ahead and go in this direction. And then let's copy and paste this event. And let's say when F is up, let's go ahead and flip the other direction, right? This is a really quick way to make these changes and just see if we are somewhat in the right. And so to start with, it's going to be in whatever orientation it's in. So let's press F down. Whoa, why did it zoom in so much on my... So you'll notice that this is working, I think, even though I'm having all sorts of crazy... Maybe F does something else. Let's go ahead and make this X, maybe? Let's try X. I have no idea why that was happening. That was a really strange bug. So let's go ahead and I'm going to double click on our mollusk so that we're there. I'm going to zoom this camera out. I have no idea why it chose to do what it did, but let's see if this works a little bit better. Okay, I have no, maybe F is a special key, but if I press down X, I go, you can see that I flip direction and I go the opposite direction, right? My actual mollusk is changing the way it's moving. Now you'll note that, right, technically this is the head and it's moving backwards, but there are lots of aquatic invertebrates that actually move backwards, so let's just go with it. Now this is something where maybe in the asset I should have changed it, and this is something else where maybe if I flip this in the X here, oh, you'll note that broke it pretty good, so let's not do that. Okay, so instead, you know, this is something where the artwork maybe needs to be flipped the other direction, but we're not going to worry about it. We'll just use it as it is. Okay, and let's go ahead and double click on our mollusk and zoom out. Okay, so we know that this works. Fantastic. So how do we get to this next step? So the next thing that we need to do to continue this is let's disconnect these, and we can just go ahead and delete these for the time being because we do not need them anymore. But what we need to do is now we need to do what's called raycasting. And raycasting is essentially drawing a line in space and seeing and then it's checking to see if and where it collides, it hits a collider, right? And that's called a raycast hit. And so what we need to do is we're going to be casting a ray straight down from the edge of our object, straight down. And so as this thing's sliding along, it's going to be hitting collider, hitting collider, hitting collider. And then once it gets to the edge, it's not going to be hitting a collider any longer. And that's the state when it switches from hitting collider to not hitting collider that we want to use as the start of the logic that will allow us to change directions. So what we need with a raycast is we need an origin point and a direction are the two minimum things that we need to supply in order to use a raycast. And so our position, our origin, we're going to determine we're actually going to create a child empty object of this mollusk so that we're going to use the position of that as the origin. And then rather than having originate, say, in the center of our object, which would be the other option, it's going to originate near the edge. So let's go ahead and create that. So I've got my mollusk, and I'm going to click over here, and I'm going to say create empty child. And once I create the empty child, I'm going to call it ground check. And I'm going to select that, and I'm going to use my move tool. And I'm just going to bring this over, and I want it to be right, kind of lined up with the outside edge of the artwork, somewhere near the bottom, and definitely outside of the collider that is on the object itself, just in case we don't want to have any odd collisions there. Okay, so I've got this set. So let's go ahead and create our raycast. So we're going to come down here to our graph. We're going to right click. We're going to say add unit. And we're going to type in, it's going to be physics 2D.ray. And we'll say raycast. And so you'll see we have origin, direction, distance, origin, direction, distance, layer mask. So to start with, we're actually going to use the second one, origin, direction, and distance. And then we will eventually go on to layer mask, but we need to talk about layer masks a bit before we do that. So, and I'd rather get this functioning part way, and then we can talk about why we need a layer mask. So what this is going to do is we're going to connect here. Our origin, right, is going to be the position of ground check. And because this is an embed, I should be able to right click and say transform dot position get, and I should be able to choose, yes, my ground check, which I spelled wrong. It's Gorund check, but that's fine. So Gorund check should be right. That's going to be my origin, and then the direction, much like we used this vector to right, we want this to be pointing down. So surprisingly enough, we're going to use vector 2 dot down. And if you do DOW, right, there we go. And so this will be my direction, right? And vector 2 down, surprisingly enough, is 0, the x value is 0, and the y value is -1. And for our distance, let's just set this to 10 for now. And what the distance does is it basically gives a maximum range for where it should be checking, right? So you could imagine if this was, say, a platformer that had a lot of verticality, so say there's like, 100 fish below this, we wouldn't want our raycast to just be shooting off into infinity, and then maybe it's not colliding with this platform, but there's another platform 20 units down that's offset a bit that it continues to collide with, so it continues to go back and forth along those two colliders, and we don't want that to happen. So we're going to set that distance, and it could be shorter, but we're just going to leave it at 10 for now. Because I don't know exactly how many units it is from here to the actual platform. So we've got this raycast happening, and so what's going to happen is, right, it's going to flow through here. We're going to be getting a raycast hit. That's what this little target icon means, is going to be generated by this. Now, that Raycast Hit gives us all sorts of information. And one of those things is it will provide the collider that it's colliding with if it's colliding with a collider. Right? And so let's go ahead and we're going to right-click, or sorry, we're going to click again. We're going to go to this Raycast Hit 2D. And what we want to do is we want to get the collider that it's touching. Now, usually, what we've done with colliders in the past is it's like, oh, no, well, now we want to compare the tag and make sure we're colliding with the player or the ground or whatever it is. In this case, we actually just want to know, is there a collision or is there not a collision? And there isn't like a true and false value that comes out of here. What comes out of this, if you're not hitting a collider, is what's called a null. And a null just means like, it's just sort of an assignment of nothing, right? There's nothing there. It's just a collider, right? Or there's no collider object because it hasn't hit a collider. And so there's a unit called Null Check, which works just like branch. And so if you type in null, you get Null Check. It works just like branch, except it basically says, is this null or not null? Is there a collision or not? And so what we want to do is we want to be checking for that null. And if it is null, that's when we want to change direction. Okay, so we've got this set up so we can check our null, right? To see if we are hitting a collider or if we're hitting no collider whatsoever. So let's go ahead and do the remainder of the logic that we need to do in order to make the decision whether to go right or left. Because what's happening now is we're not saying I'm hitting the right edge or I'm hitting the left edge. We're just saying I'm hitting an edge of this collider. And so once we've hit an edge of the collider, what we need to do is we need to be able to know what direction we were heading or moving before we hit that edge so we can go the opposite direction. And so what we're going to do is we're going to create a variable called a Boolean just called moving right. Right? And because we're going to start out by moving to the right, and then we want to move to the left. So we're going to create a Boolean, and we'll go ahead and create this on the object level, just because I know it's going to transfer more easily when we turn this into a state in our state graph. So I'm going to go ahead and I'm going to just call this variable moving right. And it's going to be a Boolean, and we are going to start that as true, right? Because we are indeed moving right when we start, and then we want to not be moving right. So I'm going to go ahead and I'm going to pull this down here as a get variable because we want to check this. So what we're going to do is we're going to say if this is null, the next thing we want to do is we want to check if we were moving right. So we can go to control and go to branch. And so now we can say, okay, if we were moving right, then we need to flip our direction and move left. So let's go ahead and say, this should be us moving right. This should be us moving left. So if it's true, we are going to switch our direction. And the last thing that we'll need to do is we're also going to need to update our moving right variable so that it is false, because now we are moving left. So I'm going to go ahead and hold down Option and click and drag to set my moving right variable. I'm going to click by the green dot here, and I'm going to create a bool literal. I'm going to leave that set to false, and I'm going to connect this over here. Now I'm going to go with my other branch. I'm going to bring this down a little bit further, and maybe I'll just double click so we can see this whole thing a little easier. Okay, I'm going to say, well, if this is false, then I want to flip my transform. Right, if I am not moving right, I want to flip my transform so I'm moving right again. And then again, I want to hold down, I'm going to select both of these. I'm going to hold down copy, or I'm going to copy it. I'm going to paste it. I'm going to move this down here. I'm going to check mark this bool because I want this to be true, because now if I've been moving left and I flip, I'm going to start moving right again. And I want to connect this. Now, at this point, we're going to introduce one other set of objects that's going to help us do any debugging that we need to do. And that is, it's called a gizmo. And what gizmos are, if I double click out of this, gizmos are basically all of these little icons in the editor window or the scene window that show us what things are doing, right? So this little line out here, right, that's the that's the collider gizmo. This is the camera gizmo, right, etc. So we can define our own gizmos, and we can draw lines and do other things using gizmos. Now, these lines that we draw will not show up in our game. They're only going to show up in our scene window. So just down here somewhere, I'm going to right click. I'm going to click create an add unit, and I'm just going to type in Gizmo. And in order to draw a gizmo, we need this onDrawGizmos event, which basically says when Unity is updating this window and is drawing these icons specifically, right? If it's static, they're probably not being redrawn, but right. But if I, hold down Option and move this around, right, those icons are being redrawn. And so, and you'll notice, right, it pulses every once in a while, turns blue. But if I hold down and click, it's blue all the time because those are updating, right? So, so what I'm going to do is I'm going to say draw gizmos, and then I'm going to come over here, and specifically I'm going to say draw line, and you'll say gizmos draw line from and to. And I don't remember if there's one that's just draw line and direction, but we're just going to use this one. Now, this gizmos draw line, what this is going to allow us to do is to draw a line that's going to match the line being drawn from our raycast. And so we're going to use the origin as our from, and then the to, right, we want it to be we want it to have the same x value as our origin, but we're just going to put in some default value, like say -50 for the y. So I'm going to go to this ground check. I'm going to click here. I'm going to say I'm just going to say get, and I'm going to get the x value. And so I've got the x value. And what I want to do is I just want to right click, and I want to create a new vector 3 and xyz. And so I'm just going to go ahead and feed this into the x, and then set the y to -50. Right? And I can go ahead and connect this to the 2. And that should all light up. And you'll see, there we go, right? Now that it's updating, this line is being drawn straight down from the center of my ground check object. And it's just going down into, not into -infinity, but it's going a ways. So let's go ahead and run this whole thing. And you'll notice, right, even though we're not doing anything, these are getting pulled on every time something updates in the window in one of the gizmos. Okay, so let's go ahead and run this, and let's see if we actually successfully did this, or if we made some mistake that we're going to need to update. Okay, and look at that. We've got our character patrolling successfully. Awesome. So this is a great time to save our work. Let's go ahead and pause this, and we will save it. Okay, so we've saved this, and I've got my 2D platform patrol in this flow machine here. So what I'm going to do, I know I want all of this stuff to be migrated over to my state machine. So I'm going to go ahead and select all of those units, and I'm going to copy them right now. And then I'm going to click Add Component. I'm going to go to Bolt. I'm going to create my state machine. And I'm going to create a new, I'm going to do this as a macro, and I'm going to save this as, we'll go down to our scripts, and I'm going to call this 2D AI state graph demo. You should call it something else like 2D enemy AI or something like that, but I've already, again, tried to redo this tutorial several times and finally seemed to be successful in my process. So yeah, so I already have those other names used. So I'm just going to save this as that. And so I've got this start state. Now, the start state isn't the one that we're going to want to use, right, with our with this patrol. That's actually the state we're going to transition to. So let's go ahead and create a new flow state, and let's title it, I'm just going to call it Platform Patrol. And then I'm going to double click on it, and I'm going to double click again so my window is full. I'm going to scoot this over to the side so when I paste this, I'm not on top of everything. And then I'm just going to move it a little bit over here. I'm not going to need this update function, so I'm going to delete that. Oh, actually, let's not delete that. Sorry, undo that. We will need this update function in order to create the transition back to the other side. So in the previous tutorial, we went through, we're not really going to need an onEnter or onExit event in here. I'm going to leave those there just in case. But what we are going to need to do is we are going to need to determine when we want to transition back to our default state. So we are going to need to know when to transition back to our default state. And that moment is going to come up sooner than we may think. So let's go ahead and actually just code this out. It's going to be very similar to what we did previously, right? We're going to want to be able to get our player's position. So let's go ahead and create an object variable, and we're just going to call it player. And we are going to make this a game object. Now, as soon as I do this, I may double click and that may disappear. Let's see. Oh, well, it changed it back to a null. So let's go ahead and make it a game object again. And then we're just going to grab Bobby and drag him down into this field. So we're going to need our player's position. So I'm going to pull, I'm going to select my flow graph. I'm going to pull Bobby out here. I'm going to right click. I'm going to say transform.position and get. And then the other thing I'm going to need is I'm also going to need the position of the mollusk itself. So I can just copy and paste this transform. And then we're going to use the vector3 distance unit. So I'm just going to say dist and go to vector3 a to b. I'm going to go ahead and check the distance between these two objects. And then whatever this outcome is, I'm going to go into let's say if it ends up being greater than a certain value, right? So we're just going to say, and we could say greater than or equal. I'm just going to say greater than, and then we can figure out what this range should be. Now, let's go ahead and create a variable for that. We're just going to call this, let's see here, let's just call it player distance or something like that, because that's what we're measuring. I'm just going to call it player dist, and we're going to make this a float, and let's just set it at 10 units for now. And then let's go ahead and pull this into our graph and connect it to this. Now, again, right, as we've done many, many times before, right, we've got this, our graph is coming together and we've done this check, and now we need to make a decision based on whether this is true or false. So we can click here, and we can just go to branch. And then from here, we can say, okay, what do we want to do if this is true, right? We don't want to do anything if it's false. We just want to stay in the state that we're currently in. But if it's true, what we want to do is we want to trigger a custom event. So we can just type in custom and trigger custom event. And then let's just say we can call this, maybe it's just out of range or something like that. So out of range. And I'm doing that without any spaces. I'm not sure if spaces are allowed in there. I'm sure they are fine. But right, that's what we want to do. Okay. So now we just need to come over here to our branch and actually connect our update there. And everything should be good to go. Okay, so let's go ahead and go back to our main thing here. And right, start doesn't have anything happening yet, but let's go ahead and right click on our patrol and say make transition. Bring this over here, and let's go ahead and just do our transition as we're at. So we're going to double click on our transition, right click, say add unit, and much like we did in the previous tutorials, we're just going to say custom event. We're going to send the flow into here, and then right, it's out of range. Now, just note that right with these custom events, this is case sensitive, and right spelling matters. So you just want to make sure that it's exactly the same thing as you typed in just, a few seconds ago. Okay, so now we can come back and let's start working on our start state, right? Which we could call start or idle. It doesn't really matter. And so let's go ahead and just double click on this. Now here, all we want to do is we want this to flip back and forth. Let's just say every half second it changes position, or maybe every second. And so we've already done some timing-based stuff with the turret example and with some of the other examples. So let's go ahead and we'll recreate some of that quickly. Now, in the past, I would explain all of these things as we go through them, but hopefully as you see them come up, you kind of remember the different units and the logic for how we got to this chain of units. But I'll kind of try and go through it again as we talk. So what we want to do in this example, or in this state, is we want our mollusk to flip direction maybe once every half second or once every second. And so we need the logic to make that happen, and we need to be able to make that happen not every frame, but we need a lot of like 30 frames or however many frames to go past before we do that flip. And so there's a unit called wait. So I'm going to type in wait. And there's actually several. There's wait until, wait while, wait for flow, wait for seconds. So what we want is wait for seconds. And because then we can just define some amount of time here. And I'm going to say wait for 1 second as my default one. And what I want to do is I want this, right? So I want the update to send some flow in here. I want to wait a second, and then I want to do something, and then I want this flow to happen again. All right, so let's go ahead and just start putting this together. So what do I want to have happen? Well, the thing that I really want to have happen is the flipping of direction. And we already have those units in our other graph, and it might just be quicker to come over here, double click, hold down Option, pull this over, and actually just grab these two angles here and copy them, and then go ahead and paste them into our state graph, right? Because we've already got them populated with the numbers we want. They're good to go, right? Okay, so we've got these two things here. And so how are we going to determine which one we want to use? What we can do is we can either use our moving right variable again, and we can use that as the way we choose, which might just actually be the easiest way to work on this. So let's go ahead and pull this down, because we're not technically moving right, but we are facing right. And we could create a separate bool that's just facing right. But I'm going to go ahead and choose moving, and if it causes an error, we will change it. I'm going to say branch, and I'm going to connect the flow from this. So after this waits, the flow is going to come here, and if it's true, I want this to go here. If it's false, I want it to go here, and then I'm going to want to set this variable to something new. What's nice about using the same variable is we should then have a pretty nice transition from, I'm going to go copy it some places, but we should have a pretty nice transition from one state to the next, because it should start at the state that it left off at when it was doing its patrol. But even if it doesn't, right, because this is just a 180-degree flip, it doesn't really matter. It's not going to look weird or anything if that's not the case. So let's go ahead and connect this. And then we just need to say, okay, well, if it's chosen the true track, then we need to make this false. And if it's chosen the false track, then we're going to need to make it true. And let's go ahead and connect this. And then we're going to need to do our final connection, right, our update into this wait function. So let's see what happens when we do this. Okay, so nothing happens for a second. Oh, you know what? There's an error in here. And so, what the error is, it says down here, but we've done this several times. We did not make this a coroutine. So let's go ahead and stop this. We're going to make this a coroutine. And then let's go ahead, and the other thing that we forgot to do is, I have a state machine and a flow machine on here. I need to turn my flow machine off, or else that is going to override whatever is coming down below it. So let's go ahead and run this again. Okay, so why is this suddenly pulsing like crazy and flipping back and forth way faster than we want it to. The answer to that question, I'm going to move this guy over a little bit. Well, let's first, well, yeah, we don't even have a transition, right? But you can see that it's kind of spazzing all over the place. The issue is that, right, this wait for a second is just a delay. It doesn't stop this flow coming from the update. It just stops it for a second and then sends it out. So what we need to do is we need to only do this. We need to use that unit once. So, right, it's no matter how many inputs it gets, it happens one time, and then we'll just need to go and reset that. So let's unconnect that. Let's stop this so that if we make changes and they don't stick, we don't get frustrated. And then I'm going to right click. I'm going to say add unit. I'm going to type in once. And for some reason it takes forever to find. Now what I can do is I can say, okay, well, I want to connect this in here. And then I want this to fire off here. It should wait for a second. Then it should make this choice. So now what needs to happen at this point is I need to be able to reset this. And so what I'm going to do is I'm just going to come out of this very final unit here. I'm going to go to reset. And then I want this to be reset on both branches. So I'm going to come over here. I'm going to click reset. I'm going to drag that to reset as well, right? It's not so pretty, but it'll work. We could potentially even have a custom event over here, and then like a trigger custom event over here and a custom event here that's setting the reset, which would, make less wires, but I don't know how efficient that is in terms of code. It might actually be kind of a nightmare. So let's go ahead and see if this addition of our once works and if we put everything in the right place. Okay, so now this thing is looking back and forth once a second. Now, if we, something that would be more advanced is to say like, oh, unless it is looking at us, unless it's facing in the player's direction, it can't, it won't see us and won't get agitated and transition to the next state. But we're not going to do that right now, right? That's a little bit more intense in terms of just the amount of programming it will take. So, all right, so we've got this. So let's create our transition from this state to the next state. And what we can do again is just go back to our state machine, double click here, come down, select this group of code, right? This might be something good to have as a super unit at some point. But we're going to go back here, double click on our start, and maybe paste this down here, scoot it down a touch, come in, and we're going to deselect all of this, right click on greater, and we're just going to say replace. And we're going to type in less. And we'll say, sure, less. Okay. So now, and then we don't want to trigger out of range. What we want to trigger is, we'll just call it in range. So in range, and that will trigger our, trigger our custom event. So let's go ahead and step back. Let's right click. Let's go to make transition, bring this down here, double click, right click here and say custom, and say custom event, connect our flow, and then type in range in the same exact format you'd used on when you just created the other half. Okay, so let's go ahead and see how this works. Now, something to note, right? I have the camera tracking Bob, and this object isn't necessarily in the scene when I want it to be. So what I'm going to do is I'm going to select my camera, and this size is set to 5. I'm going to go ahead and set that to 7. And you'll see that that's going to make everything on the screen appear smaller. And it also should hopefully mean that I'll be able to see everything that's happening on the game screen all at once. Although most of the work I'm going to be doing and checking is going to be in here. Okay, so Bob is on the fish. And let's go ahead and get Bob a little bit closer. And do you see what's happening? As I'm getting closer, I'm just barely close enough to trigger this. So you'd see as it was moving away from me, right? If I come back up here, it's going to stop, and let's see if it goes back to doing its default state. So you'll see, for whatever reason, it's frozen now. Let's go ahead and let's go ahead and select our mollusk. And instead of having our flow graph, let's go ahead and click Edit for our state machine. And let's see where this is at. So we're in our start, right? And all of this is happening, supposedly. Oh, right, this code's going on. That's fantastic. But look at this. We're not, something isn't happening here, right? And that thing that's not happening is that this is not being reset, right? And so what we need to do is we need to make it so that when we enter the state, we want to just make sure that this once gets reset, because it's going to store whatever its state was before it left that state. That's a lot of states that I just said, but it's all right. Okay, so let's go ahead and stop this. I've made that connection, and let's go ahead and try this again and see if we get it set up. Now, the other option is you could say when we leave the state, we hit reset. That would also work. But okay, so it's going, and you'll note, because this is set to a certain range, there we go. It's a little bit too far away, but you can see that now it has flipped back. If I get Bob a little bit closer, there we go, right? Now it's going to move back and forth around its whole range. Now, this does highlight an issue with using that same variable for the range, right? What might work better is, like, let's say we want this to remain agitated, once Bob's gotten into its view, into its range, we want that thing to remain agitated until Bob is further away than 10 units. Otherwise, you get this behavior where he goes a little bit further away and then it stops, right? And what we really want is maybe Bob has to be like 20 units away or 15 units away before this thing stops moving. So let's go ahead and stop this and create, go to our objects variables over here, right? And we have player distance, and let's change player distance to player detect distance, because we want that to be 10. And then let's make, I'm just going to call it player gone or something like that. It doesn't really matter what we call this, but player gone is our next one. And we're going to make this, let's make this 15. Or we could make it 20. It doesn't really matter to me which way we do that. Okay. So we're going to leave. Let's make sure that when I made this, okay, let's change this because player dist does not exist anymore and we'll get an error. We're going to change that to player detect distance. And then let's go back to our platform patrol state. We're going to come down here. We're going to change this to player gone, right? So now this is checking against 15 and the other is checking against 10, right? So we have to get closer to it to trigger it to start, and we have to be further away from it for it to stop moving once it's in that state. Okay, so we come in here, right? It is moving back and forth. If I move just a hair back like I did before, right, it's still going to move. If I get further away, it's still going to move. And there, right, somewhere over here is that boundary state of 15 units. And so then when I come over here, I probably hit 10, somewhere around there, right? And now I can go further away before it triggers it to stop. Like I have to get way out on the tail somewhere. There we go. And then it stops and starts looking back and forth again. Okay, so this has been a tutorial that shows kind of how to apply what we learned in the other tutorials about state machines to a 2D context, and it introduces raycasting as a way to do enemy AI, right? And we just raycast straight down, but there's no reason why you couldn't cast a ray to the player and end up using the distance between those two objects as a way to evaluate a course of action. There's lots of other ways raycasting is used, and its its siblings, sphere casting, and I think box casting is also one of them. But yeah, so there's many ways to use that, and so we've done all of those steps. There's one last thing that people have asked me to, in the course, have asked me to cover, and that is dealing with layers and how to arrange layers and objects in 2D mode. So if I was to select this fish, and bring it up, you'll note that it is in front of my mollusk, right? But really, this is the platform. The fish should be, or the mollusk should be on top of the fish when they're this close together, right? And in your case, this may not be the order that things are in, but right, for me, the mollusk is in the back. And so the question is, how do we make sure things are arranged correctly? So what I'm going to do is I'm going to hold down Shift. I'm going to select both of these fish. And anything that has a sprite renderer component on it, right? So all of my sprite objects, not my camera, not my scene variables, not this ground check object here, will not be part of this. But what I can do is I can do a couple things. First, there's this order in layer. Right now, everything I have is in this default sorting layer. But then what we can do is we can order all of these objects within that layer. Now, so what I'm going to do is I'm going to select this, and for these two fish, I'm going to set this to -1, right? So that's going to put all of these things behind Bob, which if I select Bob, you'll see his order is 0, and right, the mollusk's order is 0 as well. And so now the question is, do I want, maybe all my NPCs are at 0, and maybe Bob is at 1. So Bob would essentially appear as though it was on top of or in front of the NPCs when they come close to colliding, right? And it depends on, in terms of this stuff, it just depends on what you want to do, like what should be in front. Now, this order in layer is also important, right? So you can get things overlaid like this, but also if you have animated sequences of images like a coin spinning, sometimes you get crazy flickering if you don't set that order in layer. So if that's 0 and your platform is 0, some of the frames will be in front of the platform and some of the frames will be behind the platform. And so that's another reason why you want to do this. If you see that flickering where it seems like it's popping in front of and behind the objects. Now, the other thing that we can do to even have further control over where things are, and it gives us a lot more freedom in terms of moving things and arranging stuff, is we can also create sorting layers, and we can order those sorting layers. And so by default, there's just this default layer, but I've already created this foreground and background layer. To create a new sorting layer, you just click on that Create New Sorting Layer button, and you click Add. I'm just going to create one called Middle Ground just because I can. And I'm not going to say Middle Ground. I'm going to say Middle Ground. Okay, so I've created this layer, and then we can order these layers in order to, say, put certain things in the background, foreground, or middle ground. Now, the way that this works is rather than the top layer being the forwardmost layer, the bottom layer in this list is the forwardmost layer, and the top layer in this list is the backmost layer, right? So this middle ground layer that I created, I actually want to bring between my middle ground and foreground, and I spelled foreground wrong, but that's fine. So let's go ahead and grab another asset. You could grab any big, beautiful image you want. I've already grabbed this image from another demo I did, just this surreal forest recolored image. And you just, again, import whatever you want, make it a sprite, make sure you hit apply, and then just go ahead and drag it into your scene. And you'll see when I drag it in, it is already in front of pretty much everything except Bob. And I'm actually going to scale this up and hold down Shift when I do it, right? Because ideally my background is enormous. And it's not just the frame of the camera, right? You want to be able to move through this entire thing. Unless for some reason you have the background migrate with the camera, which I guess you could do. So I've got this set. So now what I want to do is let's go ahead and say, okay, well, I know the mollusk, and we're just going to put these in the foreground layer now, but the mollusk, the fish, and Bobby, we want to be in the foreground. So let's go ahead and change my sorting layer from default to foreground. That puts them all in the front. But then just to make sure this is in the background, and if there were any other items, like maybe I wanted to cut out some more trees, or maybe there's other big fish that slowly swim past as part of the artwork, but they're not being interacted with my characters. Or maybe I have multiple layers of platforms, and there's some little teleport thing that hops me back to the background layer and then back to the foreground layer. Who knows? But whatever the case, I'm just going to go ahead and change this from default to background. Right. So now all of these assets should be on top, and you'll see that if I select them, right, my mollusk is still at 0, my fish are still at -1, and this is all within the foreground layer. Right, they're still ordered, but then, right, the background layer has its own ordering. And this is just a really nice feature that allows us a pretty clean way to organize things. And you can have as many sorting layers as you want. Maybe there's an upper limit at some point, but right, as far as I know, you can have as many layers as you want. You could have one that's like just particle effects, or, you know, there's all sorts of reasons you would want to do these separate layers. Okay, and that's the end of this tutorial. So, you know, I hope your mollusk is happily flipping back and forth. Now, something to note is, right, once you're done debugging, you can always go back into your state graph, and you can delete the Gizmo code. So you can, this line can be disappeared, or you can just disconnect it from the event so that it doesn't render. But if you need to debug it later, you can bring it back in and do so. Okay, have a good afternoon.